Density depends somewhat on temperature, especially when we're talking about air. And you've noticed a correlation or a relationship between density and temperature the whole time in our science, like ocean currents, right? Convection currents. So density and temperature is really important to remember. So like I said, density depends somewhat on temperature in the air. And because the earth is heated unevenly, the density of air varies as well. Speaking of the earth being heated unevenly, air pressure is really the weight of air molecules pressing down on Earth. Most of the air molecules are concentrated close to the Earth's surface because of gravity. That is why air molecules spread apart and are thinner as we go up in our atmosphere. Air pressure is being demonstrated here in this magical unicorn. As her magical skin expands, it's because more air pressure molecules are being forced into her skin. So as you go up in altitude, it gets thinner and harder to breathe. That's why some mountain climbers spend days or even weeks acclimating to higher elevations before they climb. Air pressure affects our weather because rising air creates low pressure and sinking air creates high pressure. As the air rises, it forms clouds and sometimes precipitation.
High pressure is associated with cool, dry air and fair weather, which is nice weather. High pressure equals happy weather. Low pressure is associated with warm and moist air and clouds and storms. Low pressure is lousy weather. More on pressure.
Joining us, a very special guest.
I'm Miss Wright, the weather hippie. Let's talk about high and low pressure. One of the things the state of North Carolina wants you to know about our atmosphere is how air masses move. Knowing this information will make you a more interesting dinner party guest. Air masses move because different types of air masses exert different amounts of pressure on the surface of the Earth. Air always moves from areas where there's high pressure to areas of low pressure. So what do we mean when we say high pressure? When there's high pressure, cooler, denser air is falling from the upper atmosphere, literally putting pressure on the surface of the Earth, like this. When the pressure is low, warm, less dense air is rising up into the atmosphere, so it's putting less pressure on the surface of the Earth. In the northern hemisphere, when there's a high pressure system, the air falls downward, then spins outward in a clockwise direction. You can remember that by using the hand twist model. Take your right hand, point your thumb in the direction the air is moving. For high pressure, that's downward. When you look at the top of your hand, you can see that your fingers are twisted in a clockwise direction. In the northern hemisphere, when there's a low pressure system, air moves inward and up in a counterclockwise direction. Point your right thumb in the direction the air is moving, up. Your fingers are twisted in a counterclockwise direction. Here in the northern hemisphere, air moves down, out, and clockwise around a high pressure system. Air moves in, up, and counterclockwise around a low pressure system. I'm Miss Wright, the weather hippie, and remember, it's all connected, man.
Thunderstorms. So, thunderstorms, as you can imagine, lousy weather associated with low pressure. So, thunderstorms happen when you have warm, moist air near the surface and cool, dry air right above it in layers. And what happens is that warm, moist air creates a lift or an updraft, and it goes up quickly, and you get this instability creating a thunderstorm. And the moisture in that updraft is what produces the precipitation and the cumulonimbus or storm clouds that we see during a thunderstorm. You can think about it in the summer when you're out on a beautiful summer day and then it seems like out of nowhere in minutes, it gets cooler and the sky gets dark and there's a little breeze and all of a sudden there's a thunderstorm. Well, that's what's happening. That hot air, that warm, moist air is rising really quickly and that pressure is dropping, and that's what you're feeling. When you have severe thunderstorms, you can get tornadoes. When you've got air masses that are a warm, wet air mass and a dry, cool air mass, and they collide, creating instability in our atmosphere, you get changes in wind speed and direction, and they form really quickly. Tornadoes form really fast. That's what's scary about them. And once they form, they can create funnels. And what's really important to understand about tornadoes is that they form over land. Tornadoes are formed over land, and cyclonic storms are formed over warm ocean waters. And we're going to hear more about that from Mrs. N's Superstorm Supper.
Hi everybody. Today in Miss N's Superstorm Supper Edition kitchen, we will be making a cyclonic storm, okay? So the first thing that we need to do is to add some low pressure. And I just happen to have a little bit of low pressure here. So we're gonna add the low pressure. Get it all in there. Okay. First of all, we need the low pressure for our cyclonic warm, moist air over the ocean. As it rises and moves away from the ocean surface, it expands new air and replaces it. You know, convection. Okay, y'all got it? So the low pressure is going to be the center of the storm. Okay? Next, my dog. Next, we need strong winds. Okay? Strong wind. And last, we need to add rapid rotation because a cyclonic storm rotates very quickly. Now we just toss it up in the atmosphere and wait for the heavy rain and spiral arrangement of thunderstorms to form. Remember, these cyclonic storms can form over warm water, such as the ocean, and could be referred to as typhoons or hurricanes. Scary. There are precautions to take as they can be very damaging to people and property. Okay? If you're ever in a situation where you are confronted by a typhoon or hurricane, you should listen to weather advisories, follow evacuation protocol, and have emergency supplies. All right, guys, that's all for Miss N's Superstorm Supper Edition Kitchen. Love you, miss you. Have a good day. Bye.